Dear First Secondary, Assalamu alaikum wa rahmatullah wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Geometry Unit 4, Lesson 4. The lesson is called Follow Angle, Bisector, and Proportional Parts. In this lesson, inshallah, we are going to study the converse of angle bisector theorem and how can we prove that the line bisect the angle. Let's start the lesson. First, we are going to start with the converse of the theorem 3. If we have a triangle like this called ABC and we have a ray comes from A, for example AD. If the ratio between BD and DC equal the ratio between BA over AC, so AD bisect angle A. Again, if BD over DC equal BA over AC, so AD is the bisector of the angle. We use this ratio to prove that AD bisect angle A. Now let's see the external bisector. If we have ABC triangle and we have the exterior angle of angle A like this, and we have a ray bisect the exterior of angle A called external bisector. Okay, to prove that this line is external bisector, so we are going to connect BC like this and to intersect this line at D. Now, to prove that this line is a bisector, we need to prove that DB over DC equal BA over AC. Again, DB over DC equal BA over AC. So, AD is the bisector of angle A. Again, if DB over DC equal AB over AC, so AD bisect angle CAB externally. Okay, now this is the proportion we need to prove the line bisect the angle. Let's start example 1. Okay, in this example, in each of the following prove that BA bisects angle ABC. Number 1, here we need to prove BE bisect angle B. So I need what? To make E is a bisector, BE is a bisector of angle B, so I need to prove AE over EC equals AB over BC. Okay, so I'm going to start with this triangle. In triangle ADC. Okay, in this triangle I have DE bisector of angle D. Since DE bisect angle D, therefore, okay, AE over EC equal AD over DC. Equal 42 over 28. In the simplest form, equals divided by 6 equal 7, divided by 7 equal 6, and divided by 7 equal 4. 6 over 4 equal 3 over 2 in the simplest form. So DE equal 3 and EC equal 2. Its ratio is 3 and EC its ratio is 2. Okay, in triangle ABC, since AB over BC equals 54 over 36, in the simplest form equals 3 over 2. So AE over EC equals 3 over 2 and AB over BC equals 3 over 2. Therefore AE over EC equals AB over BC. Therefore BE bisects angle B. The next one, number 2. Triangle ABC is right angle triangle at A and AD perpendicular to BC. Okay, to prove that BE bisects angle B, so I need what? I need AB and BD and ED and AE. Again, I need AE and BD, ED and AB. All previously all the components of triangle ABD. Okay. Now, because angle A is right and AD perpendicular to BC, so I'm going to use Pythagorean theorem and Euclidean theorem. Okay, by using Pythagorean theorem in triangle ABC to find BC. So BC equals what? Since triangle ABC is right at angle A, therefore BC equals square root 40 power of 2 plus 30 power of 2, side power of 2 plus side power of 2, that's equal 50 centimeters. So BD equals 50 centimeters. Okay, now it's easy to find AD by using the rule AD equal AC times AB over BC from Euclidean theorem. This is explained in lesson 2. You can back to the video. Okay, since AD perpendicular to BC, therefore AD equals AB times AC over BC, which is 30 times 40 over 50. It's equal 24 centimeters. Okay, therefore AE equals 24 minus 9 equals 15 centimeters. So AE equals 15 centimeters. Okay, now I just want BD. I can find BD by two different ways. I can find BD by using Pythagoras in triangle ABD, or by using Euclidean BD equal 30 power of 2 over 50, because AB power of 2 equal BD times BC. So I'm going to use Pythagoras. BD equal square root 30 power of 2 minus 24 power of 2, it's equals 18 centimeters, so it is equal 18. Now I need to prove that this line bisect angle B, so AE over ED and AB over BD, and I'm going to see what will happen. Since AE over ED equals 15 over 9 equals 5 over 3, and AB over BD equals 30 over 18 equal also 5 over 3. Therefore, BE bisects angle B, internally of course. Now we have example 2. ABCD is a quadrilateral, so I'm going to draw a quadrilateral like this. Okay, so I'm going to draw a quadrilateral and I'm going to call it ABCD. A, B, C, D. Okay, in which AB equal 6 centimeters, BC equals 9 centimeters, DC equals 6 centimeters, AD equals 4 centimeters. Okay, AE bisects angle A, AE bisects angle A and intersect BD. So I'm going to connect BD first, and I'm going to connect AE like this. So this point is called E. Okay, this point is called E. Okay, now find the ratio between BE and ED. Okay, it is very easy. The ratio between BE and ED. Okay, now this is bisect the angle. Since AE bisects angle A, therefore BE over ED equal AB over AD equals 6 over 4 over 4 equals 3 over 2. Okay, so BE equals 3 units, 1, 2, 3, and ED equals 2 units. Okay, now the second part, prove that CE bisects angle BCD. So I need to connect CE like this. Okay, to prove that CE bisect angle C, so I need to find the ratio between DC and BD to prove that DC over BC equals DE over EB, or BE over ED equal BC over DC. Okay, in triangle BCD, since BE, and I'm going to start with BE over ED because it's already exists, equals 3 over 2, and BC over CD equals 9 over 6 equals 3 over 2. Now they have the same ratio. BE over ED equal BC over CD equal, both equal 3 over 2. Therefore CE bisects angle C internally. Now, example 3. ABCD quadrilateral. So I need to draw a quadrilateral like this. And I'm going to call it ABCD. A, B, C, D. Okay. AB equals 18. BC 12. ED. E belongs to AD. Okay. E belongs to AD somewhere. Just where 2 AE equal 3 ED. Again, AE 3 and ED 2. AE 3, so E here nearer to D, because AE equals 3, 1, 2, 3, and ED equal 2, 1, 2. This is the point E. Okay. EF parallel to DC. So I'm going to draw a line parallel to DC, intersect AC. Oh, intersect AC, so I need to connect AC like this. So I'm going to draw the line like this. Intersect AC at F. So this line is called F. Okay. At F, prove that BF. So I need to connect BF like this. Bisect angle ABC. Okay. To prove that BF bisect angle B, so I need to prove AF over FC equal AB over BC. It's not clear now, but I'm going to start with this triangle because we have here already parallel line segments like this, and we have a ratio exists 3/2. Okay, since or in triangle ACD, since EF parallel to DC, therefore AE over ED equals AF over FC, which is equal 3/2. So this ratio equal 3, 1, 2, 3/2, 1, 2. Okay. Now in triangle ABC, since AB over BC equals 18/12 equals 3/2 also. AF over FC equals 3/2. AB over BC equals 3/2. Therefore, AF over FC equal AB over BC. Therefore, BF bisects angle B. Okay. In the opposite figure, D is a midpoint of BC and DE bisects angle ADB. EF parallel to BC, prove that DF bisects angle ADF. And number 2, prove that ED perpendicular to DF. Okay. Now, excuse me, I'm going to call BD X and CD also X because they are equal. So let BD, which is equal to CD, called X, and I'm going to call AD Y and AD equal Y. Okay, now if I need to say BD or CD, I'm going to call X to say X, and if I need to say AD, I'm going to say Y. Okay, first, to prove that BDF bisects angle ADC. Now I will start with triangle ADB because it's already included bisector, which is DE. In triangle ADB, since DE bisects angle ADB, therefore AE over EB equals what? AE over EB equals AD over DB equal Y over X. Okay, now in triangle ABC, since FE parallel to BC, therefore AF yes over FC equal AF over FC equal AE over EB equals AE over EB, and AE over EB equals Y over X, so it is also equals Y over X. Okay, so AF over FC equals Y over X, and already AD over DC equals Y over X. Since AD over DC equals also Y over X, therefore AF over FC equals AD over DC, AF over FC equals AD over DC, both of them equals Y over X, therefore FD bisects angle ADC. This is the first required. Now I need to prove this is the first required. Now I need to prove that AD perpendicular to FD. This is the first required. Okay, I'm going to clear the screen like this. Okay, now ED bisects angle D, and FD bisects angle ADC. Okay, therefore from the previous, measure of angle ADB equals 2 times measure of angle ADE. And measure of angle ADC equal to measure of angle ADC equal double measure of angle ADF. Okay, now angle ADB plus angle ADC together equal 180. Okay, therefore measure of angle ADB plus measure of angle ADC equals 180. Therefore 2ADE plus 2 measure of angle ADF equals 180. By divided the whole equation by 2, therefore measure of angle ADE plus measure of angle ADF equals 180. Okay, ADE plus ADF gives me this angle FDE. Therefore angle FD equals excuse me, this is not 180, it's 90 degrees. Because 180 divided by 2 equals 90 degrees. So therefore measure of angle FDE equals 90 degrees. The next question. Here in this example, also we have AB equal AC and BC equal CD. Again, AB equals AC and BC equals CD. BX bisects angle ABC. Okay, XY parallel to BD. Prove that CY bisects angle ACD. Okay, also I'm going to call BC, for example M, and AB and AC N. Okay, let BC equal CD equal M, let AB equal AC equal N. Okay, now in triangle ABC, since BX bisects angle ABC, therefore AX over XC equals AB over BC. Again, BX bisect angle B, so AX over XC equal AB over BC, which is equal N over M. Okay, now in triangle ACD, since XY parallel to DC, therefore AY over YD equal what? AY over YD equal AX over XC equal AX over XC equals N over M. Okay, so AY over YD equals n over m. This is n and this is m. Therefore, ay over y d equals n over m. Therefore, ay over y d equals ac, which is n, over dc, which is m. Therefore, yc bisects angle ACD. Okay, now we have a fact. Let's study this fact. If we have triangle ABC, okay, if we draw the bisector of angle A, bisector of angle B, bisector of angle C, what will happen? Now, this is the bisector of angle A and the bisector of angle C and the bisector of angle B. All of them intersect at one point, and this is a fact. So, the bisectors of the angles of triangle are intersecting at one point or are concurrent. The bisectors of angles of triangle are concurrent, and concurrent means intersect at one point. So if he gave me in the problem two bisectors, so the third is also bisector. Let's solve the next question. Depend on this fact. We have now example 6. ABC is a triangle in which AB equal 12, AC 8, BC 16. BM bisects angle ABC, as we see here. BM, okay, angle B, and AM bisects angle BAC. Okay, find the length of AD. Okay, now we have what? We have the sides of triangle 8, 16, and 12. Now I can find AD or DB if CD is a bisector of angle C. Okay, it's very easy because AM is a bisector, MB is a bisector. That means CM also is a bisector. Again, CM bisector of angle C. Okay, since AM and BM are bisectors of angle A, comma, angle B, therefore CM bisects angle C. Okay, bisects angle C. Therefore, AD over DB equals AC over CB. Okay, to make it easy, I'm going to call AD X. So BD equal 12 minus X. Okay, now AD equal X over 12 minus X equals AC 8 over CB 16. 8 over 16 equals 1 over 2. So I'm going to make a cross multiplication. 2 times X equal 1 times 12 minus X. So 2X equal 1 times 12 equals 12. 1 times negative X equal negative X. Now send X in this side. So it will be 2X plus X equals 12. Therefore 3X equals 12. So X equals 12 divided by 3 equals 4. And this is the value of X. And AD is X. Therefore AD equals 4 centimeters. The next question. Now ED parallel to XY parallel to BC and AD times BX equal AC times EX. Prove that AY bisects angle CAD. Now to prove that AY bisect angle A, so I need to prove what? I need to prove that AD over AC, again AD over AC equals DY over DC. Okay, by looking carefully to this equation, I have here AD in the left side and I have AC in the right side. AD and AC. So I can collect AD over AC from here. So since AD times BX equals AC times EX, therefore AD over over AC equals EX over BX. This is from the proportion properties. AD over AC equals EX over BX. Okay, now AD over AC equals EX over BX. Now this is opposite corresponding to EX, and this is corresponding to, this is a star, excuse me. Okay, AC corresponding to BX. Okay, but EX over XB equal DY over YC, because the three parallel lines, EX corresponding to DY and EX and XB corresponding to YC. So AD over AC equal DY over YC, though, so AD bisect the angle. Therefore, since, excuse me, DE parallel to YX parallel to BC, therefore DY over YC, this is Y, equals EX over BX. Okay, by looking to this this ratio, EX over BX and EX over BX, this is a common ratio. Therefore AD over AC equal DY over YC. Therefore this is 1 and this is 2 from 1 and 2. Therefore AD over AC equals DY over YC. Therefore AY bisects angle DAC. DAC, and this is the end of the video. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.